Thank you, Lan, and hi to you all. My name is Moritz von Zahn. I'm a PhD student at Frankfurt University and part of this great team of academics and practitioners from various backgrounds, namely Kevin Bauer, Cristina, Mihale-Wilson, Maximilian, Speicher, Johanna, Jagow, and Oliver Hinz. And we all feel very honored to have this opportunity to present our project here at the final of the Gary Lilien Practice Prize. And we are excited to tell you how smart green nudging decreased CO2 emissions and still made us money. So the issue we are tackling in this project are product returns. And billions of products are returned every year, and these returns are very costly. Costly in the sense of both financial costs for businesses involved and also societal, ecological costs that affect all of us really. So there's really two sides to the problem of returns. On the business side, we often read of the product returns as the trillion-dollar problem of the retail industry, which refers to the amount of products returned globally. And all these returns need to be processed, of course. And afterwards, only about half of these returned products actually return to stock inventory, right? Many move to outlets, and a substantial proportion also just goes to waste without generating any revenue. So for the retailer, returns mean higher costs and more complexity. Now, the other side are societal ecological consequences. And recent estimates put the CO2 emissions from the logistics of returns on 4.7 million metric tons worldwide per year. So to give you something of a comparison, this is equivalent to the yearly electricity consumption of almost 1 million homes in the US. Also considering the packaging and discarded products, it also generates 2.7 million tons of waste. So bottom line here is returns are a problem for all of us as they drive climate change, and they also harm the financial performance of retailers. And moreover, we should keep in mind that all those numbers here are from 2019. They already have increased from that, and with e-commerce growing so strongly, are much likely to increase even further. So it's really an issue where us as marketing researchers and practitioners can make a valuable contribution. Now, our partner company, as one of the largest fashion retailers in Germany and also in Europe, and is of course therefore concerned with this development. And to get their point of view, please let me hand over to Max Speicher, who can tell us firsthand.
Yes, thank you very much. Hello, everyone. I'm really glad and excited to be here. My name is Maximilian Speicher. I'm the guy on the left, and I represent the industry side for this project in this talk. I'm a director of product design, and I've been leading user experience teams for many years, which means that we've also been in charge of anything that has to do with online experimentation and personalization. And I want to specifically mention my colleague Johanna Jagow at this point, who's also in the call. Now, the industry partner, as Moritz already mentioned, is one of Europe's largest fashion retailers with billions of euros in annual profits. Revenues, not profits, and an online shop with hundreds of millions of euros in annual revenues. The point of departure for this project was the identification of 3 strategic goals by the board of directors. 1, ESG, 2, decreasing returns and raising profits, and 3, personalization of the online shop. That is social outcomes, business outcomes, as well as making the business more future-proof by leveraging and exploring cutting-edge AI technologies. After these goals were identified, we sat down with our colleagues from Frankfurt because we had very fruitful collaborations on similar topics before. And we thought about ways in which we could potentially achieve all 3 of these goals at once. So is it possible to combine ESG, increased profits, and personalization? It turns out it is, and in the following, Moritz will show you how we did it.
Yes, thanks, Max. So seeing those goals and maybe breaking our project down to a single question, we wondered, can we use green nudging to reduce product returns in a profitable way? And Now, our main idea here is the following. On the left-hand side here, you see a combination of two nudges. The upper one is presented to customers in their shopping basket, and it just reminds them of the environmental consequences of returns and that they as customers can help the climate by choosing products carefully. The one below is shown after a purchase, which is why we term it the post-purchase nudge. And again, it reminds customers of the environmental consequences and also asks customers to pre-commit to trying to avoid returns as much as possible. Now, the cool thing about nudging is it does not restrict consumer choice in any way, and it neither gives any financial incentives to customers. It is a very subtle way of influencing behavior, a bit like nutrition labels, actually. And after some research and experimentation, that particular combination of green nudges here seemed promising to us. Okay, and now the smart part about those green nudges is we want to apply green nudging only to those customers that react in a way that increases our profits. And that's the idea of smart green nudging in a nutshell. Now, if and how green nudging increases or decreases profits on a customer level, that is best explained considering our formal model. We start by considering the profit gain from an individual customer I, which is of course broken down into the revenue minus the cost from that customer. We denote the profit of the customer as pi, and the revenue breaks down to the average price of ordered products times the demand X. That is then the number of products ordered by the customer. And that is not yet the ultimate revenue because, of course, the customer may send some products back. So we multiply this again by 1 minus the share of returned products. And now this is the revenue from the products that the customer actually kept. Okay, looking at the costs, we have, of course, manufacturing or production costs, CP times the demand, and also costs associated with returns, which is CR times the number of returned products, here R times X. Now, in our model, both returns and demand are functions that are individual to each customer, and they depend on the customer's awareness about the environmental impact of returns, which we denote as omega. And this is where green nudging now enters that model. We argue that by applying green nudging, we raise this awareness from omega to omega hat. And what is important to see here, green nudging itself does not cause any direct costs for the retailer in our model. In practice, there are some costs to it, but they are very small because implementing green nudging now in your shop, it really does not take much. The implementation costs are really negligible here. So direct costs are not the reason why we need our green nudging to be smart. The reason is that for some customers, the nudge can indeed backfire and invoke behavior that will decrease profits. And to give you some intuition, when observing the nudge, a customer could also be overly cautious to mitigate any risk of harming the environment and will not buy anything at all as a result. And so for that customer, demand X would go to 0, not making us any profit. Another example would be customers that feel patronized by the retailer or that may simply be reminded of the possibility of free returns and as a result may actually return more products and increase R. So it really comes down to the functions R and X that are individual for each customer, if nudging increases the profit pie or not. And this is why we need green nudging to be smart. Formally, this means to only nudge customers for which the first derivative of that profit function with respect to omega is greater than 0. Okay, so how did we approach this in practice at the retailer? We first conducted a large-scale field experiment at the German online store of our partner company. And in this experiment, 1 million visitors were randomly assigned to one of two groups. In the control group, visitors interacted with the default shop, no changes made. But in the treatment group, visitors were subject to our green nudging. So they saw both the basket nudge while shopping and the post-purchase nudge that we saw also at the beginning. So in order now to evaluate, by the way, this left us with tens of thousands of purchases in each group that we could then evaluate in terms of demand, returns, and profit. Okay, to begin with, we simply compared all customers that were nudged so the treatment group, with those that were not nudged, the control group. And we refer to this as naive green nudging, right? Because we simply apply green nudging to every customer in the treatment group. And as we can see here, naive green nudging already yields some impressive results. So we can see its impact on returns, demand, and profit in these three columns here, respectively. And returns decrease significantly by 3.8%. Demand seems to go down a little. We see a tendency by 0.65%, but this is not significant. And the profit, importantly, the overall profit increases significantly by 9.2%. Now, the retailer liked this, of course, very much already, but we were thinking of our model and immediately wondered, seeing those results, can we get even better? Can we improve upon this naive green nudging by making it smart? Again, our goal when making green nudging smart is to only nudge those customers for which profit increases on an individual level. And we do this in two steps. First, we collect and enhance customer data that we collected in that field experiment. That is really the basis for our smart green nudging simulation. And second, we use state-of-the-art causal machine learning to then predict the nudging effects on profit for each customer. So let us look on this first step regarding the data first. We distinguish between three types of data in our project to characterize our customers. First, on the very left here, we have basket data, and that is the data that we really track by default in the shop. For example, it's the number of products in the basket that are branded as sustainable, but also whether the customer shops fashion for women or for men, for both, for children. And second, we have that digital footprint data, as we call it, in the middle here. And that refers to traces that customers leave behind when visiting our online shop. This can be their operating system, the internet browser they use, but also the location that is associated with their IP address. Of course, we did not consider any privacy invasive data, such as the browsing history, and also the IP location is, of course, only approximate. And then third, we also leverage data from third parties here on the very right. And here we use both regional statistics, such as the share of bicycles in traffic in a given district, or the share of people voting for the Green Party in a district, as well as data from the SEP data, that is the socio-economic panel in Germany. And SEP data is based on that large-scale survey that is conducted in person with more than 30,000 representatively chosen individuals in Germany. And that survey really covers all kinds of topics reflecting attitudes and preferences of German citizens. We found this third-party data to really be essential for making smart green nudging work. We found it essential to determine which customers to nudge and which not to nudge. So let me in detail explain to you how we leverage that third-party data that was so crucial for the success of the smart green nudging simulation. So on the right, you can see a map of Germany. And in our experiment, all of the purchases considered, they stem from roughly 2.6 thousand unique IP locations that are shown here on the right. And the problem is here that the locations, well, they are just locations, right? They are just coordinates basically, and do not incorporate any information such as if that area is rich or poor, for example. And even if we found a way to pre-process those coordinates somehow, we would not really be able to learn anything from regional patterns that we might identify with regard to the green nudging effect. So instead, we use that location of customers and we consider both the 96 regions in Germany for which we aggregate SERP data, that large survey, and the 401 districts for which we can aggregate public statistics that are freely available on the internet. And as an example here, let us consider the Rhine-Main region that you see here on the right. That is a region where Frankfurt, and thus also our university, is located. So with regard to our field experiment, as you can see here, more than 3,000 purchases in that field experiment stem from IP locations in the Rhine-Main region. And so you could say, conditional on being in that region, we can calculate the average effect of green nudging on profit, which here is a 12.9% increase. And if you recall it, overall, we saw a 9.2% increase. So only by looking at this manually, we can already see that green nudging is particularly profitable for that specific region, for that Rhine-Main region. And with regard to our third party, the data, the SEP data, how does this here come into play? Well, more than 2,000 participants in that large-scale survey also live in that region, in that Rhine-Main region. And they answered questions such as, are you worried about the environment? Have you donated anything to charity last year? And we can average across the answers of those questions and other related ones. And we argue that, well, this basically gives us a proxy on attitudes and preferences of citizens in that region. And we argue that on aggregate, on a large scale, this also tells us something about our customers in that region. And as you can see here, the average answer on the question on worry about the environment, for instance, is on a 3-point Likert scale, 2.4. And of course, we infer those aggregates not only for Rhine-Main, but really for all regions in Germany. And following this example of the worry about the environment, we can, for instance, do visualizations of how those attitudes are distributed and can see patterns that, for instance, in the more rural areas of Germany, in the very east here, but also in the southwest, in the Black Forest, people are just generally less concerned on the environment, particularly when comparing it to densely populated areas here in West Germany. And this is how we added this third-party data on the regional and district level to that individual customer data that we have in our shop. So that is on the data perspective. Now, in order to make use of this variety of data, we proceed to the second step of making green nudging smart, and that is using causal machine learning. So when we started the project, this was a really tricky part in a way, because having these rich big data characteristics, that also meant that analyzing and building a prediction model is quite challenging. The sheer number of characteristics make a manual analysis of interaction effects, for example, by regression, hard if not impossible to do. And similarly, just mining all possible combinations of customer characteristics, that is computationally also almost impossible, and is also bound to at some point find a pattern purely by chance, which will then not replicate, right? Which will not work on new customers and unseen data. And now traditional machine learning, of course, might be able to process this type of data, this volume and variety, but it requires a ground truth to train it, right? And we don't have that in our case. On an individual level, we never know the effect of green nudging. A customer has either been nudged or has not been nudged, and we can never observe both and thus do not know the true effect that we want to predict. So traditional machine learning is also not really an option here. Thankfully, 2 or 3 years ago at Stanford University, Susan Effey and Stefan Wager developed a method to tackle exactly this problem. And this causal machine learning method called causal forest, this method can predict that unobserved effect of green nudging on an individual level, on a customer level. And it can handle a large number of customer characteristics and can also reveal those complex and nonlinear interactions between those. So in each run of our smart green nudging simulation, we randomly draw 70% of that data from the feed experiment. We use that data to fit and tune our causal machine learning system, and then we let that system predict the green nudging effect for the 30% of unseen test data. And so based on the actual outcomes from the feed experiment, we can then evaluate the performance of smart green nudging. So speaking of, we wanted to find out if smart green nudging really outperforms naive nudging, so naively nudging all customers. So we compared both across 30 runs of that simulation that you can see in the table here. And indeed, comparing the two, we are able to further decrease returns significantly. The demand also very slightly increases, but again, not significantly, similar to naive nudging. And the profit also strongly significant improves when comparing the smart to naive green nudging. So we actually did achieve making green nudging smart in a way and selectively nudging customers, which ultimately further reduces CO2 emissions and also raises profits. So the management of our partner company was quite enthusiastic about these results, but they also immediately wondered why, right? Why is this happening? What exactly is smart green nudging doing? What characteristics determine if the customer is nudged or not nudged? And for us, these questions were tough to answer because state-of-the-art machine learning, including causal machine learning, is still a black box. So it achieves high predictive performance, certainly, but the mechanism behind the prediction is not transparent to us humans. And this black box character can be very problematic. We might not trust the outcomes of machine learning if we do not now know how the customer data drives that particular prediction. And importantly, also, as Max has said in the beginning, organizations are striving for greater customer personalization. And this would actually be a great opportunity to learn from machine learning and learn some insights about our customers. And to leverage this, to actually take advantage of this opportunity, we aimed to open the black box, and we used algorithms from the field of explainable artificial intelligence, or short explainable AI. And this post hoc algorithm that we used allowed us to see how the information going in, and that is the customer characteristics, relate to the information going out. That is a predicted effect of green nudging. And with that algorithm that we used, we could even do this on an individual level, right, on a customer level. And now these explanations that we gained through the use of that method, they are of course highly nonlinear, right, as are the patterns on which causal machine learning relies here to achieve that performance. But there were some examples where we could see a very clear relationship between customer characteristics and the predicted effect of nudging. And one example here is the role of the number of duplicate products for that prediction. And if you look at that graph, every dot represents a single observation, so a single customer in our online shop during the field experiment. And the color of the dot represents the value of that characteristic for that customer, right? So red is a high number of duplicate products, and blue is a low number of duplicate products in that shopping basket of that particular customer. Now, on the horizontal axis then is the impact on the predicted treatment effect. So on the predicted effect of green nudging on profits. And as you can see now, looking at the distribution of the dots and the color, if customers have many duplicate products, right, the red dots, for those customers, green nudging is predicted to strongly increase profits, so to be very successful. And this pattern here, this was actually very stable and robust results from that simulation and gave us an important indication, namely that green nudging might actually help to tackle the problem of bracketing, where shoppers order multiple products in multiple variants, sizes, colors, with a pre-made intention of sending at least one of those products back, right? That's bracketing. That is an example of a valuable insight to the retailer generated by explainable AI and our causal machine learning model. And using these insights in the future, we hope to develop tailored countermeasures, really, right, for reducing returns even further. So together with domain experts, we could analyze then the insights by explainable AI, identify the types of customers for which green nudging is ineffective, then come up with a different solution, maybe even a different nudges for them. So for example, the customers that may simply not care about the environment, they might care about the effort they themselves have to put in to process a return, right? They have to do the repackaging, they have to go to the post office, etc. Maybe reminding them of this effort will decrease returns for that group of customers. Just to give you an example of measures that we could try to develop using those insights by explainable AI. So regarding transportability and impact of this project, regarding the transportability, I really want to stress that that green nudging that we relied on, that is very easily implemented at low cost and really in any online shop. It really is just 2 banners displayed in the shopping basket and on the post-purchase page, respectively, right? So the results that we gained from naively nudging all customers, that should be easily be achieved in other online shops. But also our smart green nudging application can be applied easily, I would argue. The causal machine learning model, for example, is based on econ-ML, which has just been released by Microsoft Research as open source. So anyone can use it. And the same also applies to the explainable AI method that we used. Now, in terms of impact and remembering that first slide with the 2 big downsides to product returns, our project took away 3.8% of this pile of returns in case of the field experiment, in case of naive nudging, and even 4.7% if we consider the smart green nudging simulation. And just assuming that we achieved this on a global scale, we could reduce CO2 emissions by up to 220,000 metric tons per year. And again, going back to this comparison that I like to make, this is the equivalent of the electricity consumption of more than 42,000 homes in the US. And of course, waste also is also reduced due to fewer discarded products, less packaging, etc. So that was the environmental side to it. What it means on the business side, that we will hear from Max again, who will then also wrap up this presentation.
Yes, thank you very much, Moritz. Thank you very much for the presentation. And to conclude, I have the honor to translate the numbers that we have seen into the concrete, tangible outcomes for the company that we did in fact measure. So first, the 9% increase in profits from just the naive green nudging means millions of euros of added profit per year. And all that with an effort of just 2 person days. We had 1 designer and 1 developer working on this, and the experiment was up and running in 2 days. Needless to say, as soon as we saw the results from the field experiment, we reported to management, and they decided to put the green nudging live for all online customers in Europe the very next day. And that's what we did. We flipped the switch, the nudging went live, and it has been generating millions of euros in profit, and it has saved tons and tons of CO2. Second, in our Net Promoter Score feedback, we saw an increase in customer comments positively highlighting our efforts to reduce returns and therefore also carbon footprints. That is, we're being perceived as a more sustainable company. And third, by applying these novel artificial intelligence methods and opening the black box, as Moritz said, we have provided very, very valuable insights for other personalization efforts that are going on that particularly also involve this third-party data. And this is ultimately making the company more data-driven and more future-proof. So overall, I believe we have a pretty positive ROI for both society and the business. And thank you very much. And we're happy to hear your questions.
Thank you. This is an amazing talk. And we already have some judges already have questions. I'll start with John.
This is a really cool paper. It was really interesting on multiple levels. So congratulations for some effective marketing science, and congratulations on some effective impact for your business partner. My question is, I really have no questions about the methodology. The front end of this is very interesting. I'm really focused more on some of the results of the explainable AI analyses, the Shapley value and the data ablation that's in the paper, which I commend you on as well. A lot of times it stops with the AI magic, and really appreciate seeing those data and the opportunity there to use this to build new theory or to validate theory. So I had just one puzzlement and a question. The puzzlement was, the demand value was appeared in as one of the explanatory variables. In fact, it was the largest one, but that's not too surprising because it's on both the left side and the right side of the equation. And so I was a little curious about what you make of the huge effect for the demand value and what the business implications might be for that, other than just the obvious statistical effect. So that was the puzzlement. The question is about the relative impact of bracketing versus the individual level data. The Shapley values showed kind of equal effect size. The Shapley values were roughly the same, but the data ablation showed a big jump when you added the social data, when you added the individual level data. And I was curious what you made of that and what the potential implications might be.
Yeah, thanks very much for the question. I'd like to take the liberty and maybe start with your second question first. So regarding the data ablation study, maybe I can also, I think I have it on the slide, maybe you can put it on for that discussion. Because as you've correctly said, according to the feature importances by our explainable AI techniques, those basket features are actually among the most important predictors to get that green nudging effect. Nonetheless, as we can see here in our data ablation study, for example, here on the right, we can see that that increase in profit powered by smart green nudging over naive green nudging only really lifts off after adding those third-party data sources. And that's also for us the really interesting part, that even though the basket data itself seems to drive the prediction more strongly, without those contextual features, without knowing how much the region the customer lives in worries about the environment, we're not able to really get to the potential of smart green nudging. And that's also what we looked into a lot, and what we found most interesting about the project, about the value of this third-party data source. Yeah, so it's a very good question. Regarding the demand value, don't know if anyone wants to jump in. Yeah, from my perspective, yeah, we saw the chat values. See if I have it on slide as well. As you mentioned in the paper, that the larger the basket is, the more products we have in the basket, the more effective is the nudge. And of course, my simple interpretation of this would be customers that shop a lot might have more wiggle room to then decide on, okay, I might not go for this or that project, this or that product, and thus we would rather see an effect of those for those customers that shop a larger basket. But it's an interesting question. I wonder, I don't know, my co-authors have thought about that as well, probably.
Yeah, hi. This is Kevin. Let me maybe quickly jump in. So thank you very much for these questions, and also for Moritz already pointing out one of the important facts here, namely that essentially all of the kind of explanatory power of the model comes in when we add this third-party data, which suggests that there are very high nonlinear or highly complex and nonlinear relationships there that relate somehow to all of these basket information. And my intuition for this observation that it's really the demand that also has strong explanatory power is that the demand value in and of itself also kind of interacts with the duplicate products, right? Because the more demand I have, it turns out in our data that the more likely people are also to send something back. And so what my intuition here would be is that parts of this demand value effect also comes from duplicate products. And we are currently doing additional analysis to really dig down on these heterogeneities, which naturally there are a lot, and we try to see using marginal plots what's really going on there. But as I said, first indication and first intuition we have here is that the demand value also somehow has an effect which coincides with the effect of the duplicate products in the basket that we see here.
Great, thanks. I'll just once again reiterate that demand value is on both sides of the equation. So it's not surprising that it's got a big impact because it's part of the DV as well. It's at least part of the function. That's right.
True.
Thank you, John, for your question. Phil, you're next.
Thanks, Lan. Fascinating paper. Thank you, guys. Really appreciate it. if I understand the main result, and tell me if I'm getting this wrong, the nudge doesn't really have an impact on reducing sales for the company, but it does have an impact on reducing returns for the company. So does that mean that the effect of the nudge is basically that people still buy the same stuff and just rather than return it, they just throw it away, or it sits at home and they don't use it?
That's certainly a possible interpretation, although I would argue a bit pessimistic. Since we do show the nudge, it's an excellent question, by the way. We thought about that question also a lot. What actually happens to that reduced returns? It could also be that people select clothing more carefully. That would be the more optimistic one. So it's in fact not returning or not returning. I just keep it and throw it to waste myself. But maybe I have made a better choice in the first place. But it is true that it could be that a substantial part is just kept that would have otherwise not been kept.
Yeah,
At least that's my thought about it.
Yeah. I mean, it would be super interesting if you had some evidence that people are making different shopping choices as a result of the intervention. Otherwise, it's hard for me to rationalize why there's no effect on sales doing this. Yeah, anyway, it's an interesting point.
It's interesting. We should, I guess we should dig into that product level within the basket more and really see what's happening on that product level. Yeah.
I think another way of saying it is, I actually am surprised that you didn't find bigger effects on sales, negative effects on sales from doing this. It's a little surprising to me, but it would be interesting to study that further.
Yeah, I have a related question. So I was keep thinking about this smart nudging, right? So it seems like it has a pretty big impact. So I'm trying to figure out what's the basic intuition. So it seems to me the basic intuition is, I say for some customers, I say if I'm on the bubble for a particular item, and when I see the nudge, right, then I realize, oh, maybe I should be more environmentally friendly. If I'm not sure if I really like this dress, I shouldn't buy, right? I think that's kind of the intuition you are trying to motivate at the beginning. Mm-hmm. So on a related point, I'm thinking about among your analysis when you did the, causal machine learning, what type of customers do you think, this nudging could potentially hurt their sales, right? So they may decide to drop off. They decide not to make a purchase. Do you observe any particular pattern? Because I think so far you have demonstrated for certain type of people, like for people who are more environmentally friendly,
mm-hmm.
More conscious about environment, for them the effect is bigger, stronger. But have you identified the subset of customers that for this type of green nudging is actually could potentially hurting them?
And hurt in the sense that demand is hurt, or that the customer is
demand.
worse
So they
off?
decide not to buy, right? They decide,
Mm-hmm.
but I think that's your motivation of why we need this, a smart nudging instead of just nudging everyone.
Yeah. To be frank, we have not looked into the subsets just with regard to isolated demand, but we've always considered it together with return in that profit function. I could very well imagine that what you say is true, and that there are some subgroups, probably some maybe overly cautious, very environmentally friendly people that refrain from buying altogether, and they lose out on products and we lose out on profit. Could imagine that being the case. Maybe to add that here, what was also interesting to see for us that there might even be, we saw some evidence or a tendency that there might be customers that are more eager to buy products seeing that nudge. Another analysis that we did, we saw that the share of converted baskets, right, that you can see here. So the share of baskets that were converted to a purchase was actually slightly higher as a tendency for the treatment group. So this effect was not significant. So we did not explicitly include that in the analysis, but just considered overall profit. But this also made us think that there might be customers that refrain from buying, as you mentioned, seeing that nudge and being a bit taken aback and not buying products at all. And there might also be customers that see that nudge and think, okay, this is a really cool company. They think about the environment and I might actually buy more. Or now I'm more eager to complete my purchase. So those are both topics that we are definitely eager to dig into more deeply.
Yeah,
I mean, maybe I can add.
Go ahead.
Sorry. Maybe I can add one or two sentences here. I think that this these results that we present here, and also this discussion that it seems to inspire, is one of the very valuable and great things that we think explainable AI can now make a great contribution, right? Because it was pointed out that using black box machine learning approaches where we simply have some kind of black box prediction and don't understand at all what's going on cannot help us to, on the one hand, create new knowledge and new theory, right? And on the other hand, it does not help us to kind of or confirm the theory that we have from the beginning. And so we really see this paper and this methodology that we apply here as a starting point to conduct new research questions, to go into the details that we have here, and also do more consumer studies to really see what's driving the results in detail, and also what are the more permanent changes. Do we kind of influence people's awareness more generally in the long term, because we on the one hand make them more aware of the consequences of their actions, but maybe this not only changes their behavior in the backsending domain in this marketing, but it could also be that they kind of change their behavior in other domains as well. And I really like the comment in the chat here, which says that maybe some of the customers kind of re-gift the bought product. I really like this idea, and we should definitely get into this point more in detail, because it really seems that they find, or maybe they really find a different use of the product that they bought, because as it was pointed out, the demand does not really react. However, it's the return rate that's driving our results here.
Yeah, I think also a related point, I was also thinking about, there's like this short-term effect. You guys already mentioned there's a short-term effect versus a long-term effect, right? So like in the short term, we don't see like changes in terms of sales, but in the long term, there could be actually very positive impact. People could consider the focal retailer as being, environmentally friendly, and it was really kind of select certain type of customers would self-select into purchasing from the focal retailer, right? I think that also in the long term impact could be pretty big, actually. So I wonder if you guys thought about any ways to measure the long-term impact.
Well, as I mentioned, we're permanently monitoring the NPS results or values that have also been mentioned in the chat right now, specifics of which, of course, I can't disclose. But I can tell you that the positive comments increased, so that supports the theory of people actually consciously buying products they are less likely to return, because they also perceive the retailer as being more environmentally friendly.
Yeah, exactly. Right. I think in the long term, if you attract the right set of customers who are more careful when they make a purchase, will return less, is really good for the company, right? Yeah.
So we're definitely monitoring these NPS feedbacks all the time anyway. The rest of the theories is also very, very interesting, but we yet have to dive deeper into those with more qualitative research on the consumer side, of course.
Yeah. Okay, I think we're right at time. So
just one quick answer. Yeah. I don't know if that has been answered in the chat. Just to clarify that quickly, do sales actually include products that are eventually returned, or are returned products deducted? No, those sales X that we report include all products that the customer ordered, so including those that the customer eventually returned. Okay, sorry to jump in there.
No problem. Thank you so much.